Howdy, welcome back to the shop. So we're partying on here with our Onan generator modernization project, and you'll remember on the last time we met I had just developed this tracing of where the bolt hole locations were. Now this was an approximation. You may have noticed while I was working on things it kind of wiggled on me. You know, that happens. That's just how the world works. So I took the tracing and I measured with my precision square, and I think maybe a 12-inch framing square too. So, but I measured this out. Now, so I measured, made me another set. This was attempt number 1, and I ended up with these holes being 1/8 of an inch too wide after I measured this out. So here's attempt number 2. This hole was 1/8 of an inch off or so. So here's attempt number 3. This hole, I moved it over, decided it was in the wrong spot, moved it back this way a little bit, decided that was in the wrong spot, so I needed to come a 1/16 back. So now I said all of that to say this. The rest of the world uses the metric system. Americans don't. There's 1,000 reasons why, but I will say this. If you have ever been a draftsman, you will understand why things are drawn the way that they are. A draftsman's, and I'm talking before computers, a real draftsman that sat at a real drafting table, you know, in white sleeves and a tie, with his ashtray next to him, maybe with a mechanical square if he was really fancy. But he sat there for 8 hours a day, and this is what he did, was draw drawings on mylar or paper, but he drew drawings. That was his job. Now, I trained to have that career. It didn't really agree with me. I can't stay inside for that long. But I do know what a draftsman's job is. On a drafting rule, or on the arms of your drafting square, it is graduated in 1/8 or 1/16 of an inch, unless it's a scale rule, and then it'll be usually graduated in like half scale or quarter scale. But when you start making A-size drawings or B-size drawings, or sometimes even C-size drawings of parts in 1/16 scale or 1/8 scale, the divisions for 1/8 of an inch is really small. So typically on older stuff like this generator, which you know this was designed probably in the 50s if it was produced in the 70s, or at least it was designed in the 60s, it was hand drawn. A draftsman, or actually a fleet of draftsmen, sat at drafting tables in an office, smoking cigarettes and drinking coffee and making meticulous drawings. And that's just what they did. But they did use a lot of shortcuts, and engineers would hand the draftsman a scribble on a napkin from a bar, because engineers are idiots. So the draftsman would take the engineer's scribbles and make that into something. Usually there would be a sketch that would be sent to the engineer. The engineer would put his tolerancing and notes on it, again written in Egyptian hieroglyphics or Phoenician alphabet. And then the draftsman would take that back, and then the draftsman would draw it, send it to the engineer. This happened 3 or 4 times until a part was made. Said all that to say this. Draftsmen and engineers were lazy, still are. So most of your dimensions will be in 1/8 of an inch. Some of them will be in 1/16. This ended up being, okay, from the edge here. Now I chose this arbitrary 1/2 inch just because that's what worked out. So we've got a 1/2 inch here, The first hole is 2 1/4 inches from this edge. These holes ended up being 3 15/16 from this edge. That's where they ended up being. I got 4 marked here, but it is 3 15/16 from this edge. So the center line of this go up 1 1/4 inches, and then you've got these holes down 2 1/2, and then you've got these holes, and this hole is 7 1/4 inches off of this edge. So that's how things typically work on American-made stuff up until, at least until the computer era. You know, late 80s, early 90s is when we really started seeing things that were CAD/CAM manufactured. You know, where you had a computer-controlled CNC mill that was just, you know, he'll stick a hole wherever you tell him, and there's probably been no human hands touched a physical drawing in the development process. You know, a lot of the old-timers, the old-time engineers and draftsmen, I'll say this, all of the computer modeling that we do now, they did it in their heads. So they just knew instinctively that this part, if this part has to fit in this hole, and you want this to be nominally 1 inch, then you need to tolerance this 1 inch plus nothing minus 5/1000. This hole needs to be 1 inch plus 5/1000 minus nothing, and that will give you a fit of between, you know, clearance or no clearance or slight press and a 10/1000 clearance. So, you know, they had to instinctively know these things and think them out in their heads. There was no computers. And I'm telling you all this because that critical thinking is kind of gone now. So, back to our project after a 7-minute rant. I'm so sorry, guys. I wanted you to see how I developed this from that. So, we've got our actuator. I'm going to make some little studs to screw into this and Loctite them in. And that will allow us to mount our actuator to the generator. So here you can see the back side of her. I had to take and put it on the mill and cut out just a little relief here. There's a piece of tin that sticks down from the top, and I thought my gasket would space it out just enough to clear that piece of tin, but I don't think it would. So anyway, I just milled out a little slot right there. I hate to get that close to a hole, but there's my studs for the actuator. They are Loctited in with red Loctite and then staked from the back side. And then once everything was done, I put this on the sander and sanded it as flat as it needs to be. I mean, it's just soft aluminum, so it will twist, warp, move, and conform. So after test fit number 39, I decided I need a little clearance right here to clear the points cover. There's a cover over where you adjust the points and the starter kick-out switch. And so I clearanced that out. So let's see if it'll fit now. So there you can see my clearance issue. This cover over the points, I've got about 1/4 inch gap in behind there now. And then behind that, between the bolt and that cover, there's a good strong 1/8 inch. Clearance is clearance. I don't care how much it is, as long as it ain't going to touch when it vibrates. So, because this might vibrate just a little bit, and this might vibrate just a little bit. And I don't like pieces bouncing off of each other, especially something as thin as this little piece of sheet metal. So, we'll back everything back out and reassemble it for the last time. So there we go. That'll fit right up on there like such. Still got room enough to get in here to get to the wing nuts over the points. If I had both hands and the camera wasn't in my way, I could get right to it. It's going to be tight, it's going to be hard, but it's doable. And that was the goal. So let's put a little blue Loctite on that. Now, I use either Loctite or anti-seize on everything. And the reason being, especially with blue Loctite, you can get it back apart, but it seals out the moisture that will cause corrosion on a bolt. So I've taken stuff apart that's been together for a long time in nasty corrosive environments, and it was put together with blue Loctite or other colors, and it came apart. And anti-seize or grease or anything. Basically, you're not really concerned so much with lubrication as you are sealing the moisture, dirt, and water corrosion out of the threads. So blue Loctite, if you want her to come back apart, like if you're going to regret your decision or you think you might regret your decision and put it together, use blue. If you're sure of yourself, use red. It's kind of like at the election polls. If you're pretty sure you're going to regret it, you might as well vote blue. If you think you won't, now vote for the Republican. They'll probably all let you down. Now I am going to torque these. Every fastener that you come across has a torque spec. It may not be written down, it may not be something that you know about, but every fastener has a torque spec, and it's not tighten her down till you strip 2 threads and then back her off quarter turn. That's not really good. So, with that nugget of wisdom, courtesy of the Generac man in Wisconsin that I learned that one from, I will bid you good day. Y'all drive safe and watch for deer. That'll work good. I might go this way with it.